Good evening, everyone. It is once again Ted the Speed Learner, and this particular video response is going to go out to Crazy Josh Cravey and D. Lukens 9, and that's because I desperately need their assistance. Okay? What we're going to cover here tonight is parametric functions, the Bezier curve, and completing the square. And yes, you can combine the three to draw Bezier curves. And I will illustrate that to you in this particular video. Now, the first thing we're going to do is we're going to go back to Euclid Book 2. And I think this will look very familiar to you if you have ever studied Euclid Book 2. And I did a whole slew of presentations on my YouTube channel for Euclid Book 2. If you want to know where all that is, I have playlists on my YouTube channel. One of those is the Euclid Elements playlist. Why did I physically draw out all those drawings? Because you can do the same thing, and I wanted you to see that. I know there's a lot of videos on YouTube now that show you Euclid Book 2, but they never physically draw it out. I do, because I expect you to do the same thing. See what I mean? Okay. Now, we're going to go into the farming community. As you know, in the farming community, they have acres. And acres are perfect squares, or they're supposed to be anyway. Okay. What if you wanted to add additional area to an acre of land? Well, here's part of that area you're going to add, and here's part of that area you're going to add, okay? And these two amounts are going to be exactly identical, okay? There's the same amount of land here as there is here. See what I mean? Now, as you can see here, this is a perfect square right here. This is a perfect square. So this would be an acre, okay? But we're going to add a little bit more land to make it a bigger acre, okay? Now, to do this, we split apart the land that we're going to add, but as you can see, this is not a perfect square anymore. Okay, when we added this area here and we added this area here, we turned this from a perfect square into, well, kind of a rectangle type thing. What do we have to do to this to make it back into a perfect square? Well, I'll show you. We have to do this and this. As you can see here, that is also a perfect square. And that's what we're doing. Okay? Now then, how do we represent this algebraically? Well, we do this. Just like that. X plus y times x plus y. And now we're going to use the FOIL method to solve this. Okay? What is x times x? Well, that's x squared. What is x times y? Because the FOIL method says we have to multiply the first digits here, which is the x's, okay? Then we have to multiply the outer digits, which would be this one, and then, and I'll show you this, we're going to multiply x times y, and we get xy, just like that. And then we have to multiply the inner digits, which are these two right here, the y and the x. Y. I know that looks like a horrible y there. Let me try to erase that, and we'll do it again. There we go. And y. Now, we have to multiply the last ones. The y here and the y here. Y times y is y squared. And that's what we get. Okay? Now then, this is x squared right here. This is xy. This is xy. And this is y squared. Let me say that again. This is x squared, this is xy, this is xy, this is y squared. So x squared plus xy plus xy plus y squared gives you this whole area, which makes your bigger acre. Getting the picture here? Now then, we don't want any unnecessary terms. Well, what is xy plus xy? Well, I'm going to tell you what that is. That is, let's say, set it right over here, x squared plus, hold on, 2xy plus y squared. Now, where do we get the 2xy? Well, xy plus xy is 2xy. That's what it is. Because basically you have a number 1 here, and you have a number 1 here. That's 1xy, 1xy. Well, 1 plus 1 is what? It is 2. That's where we get this. Now then, now that you understand this basic concept here, I have a hyperlink down here in the description below, and I want you to start taking a look at that as I continue on with this particular presentation. Okay? Now we're going to erase a bunch of this, and I'm going to illustrate some stuff to you. Alright? Now we're going to start with the very basics here. I'm sure you wrote all of that stuff down already. If you didn't, rewind the video. That's right, rewind this video, write down all that stuff, and then we'll proceed on. Okay? Now then, that's the nice thing about videos. You can actually rewind them and then do it again. Okay, so now we have x squared plus 2xy plus y squared. Or, in other words, we'll have x plus y times x plus y. Now, what we're going to attempt to do, based on that website that I showed you, is we're going to replace all these terms. Replace them with what? Okay. Well, let's take a look at their equation. This is going to be in reference to the quadratic Bezier curve. Okay? I don't know what that was all about, but okay. Anyway, let's go ahead and do that. Now then, what they have here is the b of t. And it's going to be equal to the following. 1 minus t squared p0 plus 2t times 1 minus t p1 plus t squared p2. Okay. Now then, let's take a look at this here. We have a function. This is the b of t. This is a function. Okay. Now we have terms. This is the 1 minus t squared. Now then, what is this p0? Okay, there are points on the lines on the web page that you are seeing right now. Okay? And this 0 here is saying that this is a subscript. Okay? We have 3 points. Alright? But they all have subscripts. P0 is one subscript, P1 is another, P2 is another. Now the 0 and the 1 and the 2 here, they are all subscripts. Okay? Superscripts are like these, your exponents. Okay? If you have a superscript, you probably have an exponent. These indicate which point you're discussing in whatever you're discussing. In this case, we're discussing points on 2 separate lines. That's what we're discussing here. Okay. Let's go through this, shall we? Now, how are we going to generate all this? Well, let me ask you something. If you have 1 minus t, and I'm going to go ahead and put this right here. Let's erase that real quick. Let's do this a little bit further to the left, and I want to make sure that you guys are getting this. Yep, you're getting this pretty good. All right, good. Now we're going to put it right over here. Now you notice here that we have two parentheses, and that's because of this. You have the 1 minus t here. And I'm going to put this like right there. And then we have 1 minus t here. And we'll have this one like this. Now what happens when you multiply 1 minus t times 1 minus t? You get 1 minus t squared. That's what you get. Okay. Now then, how do you get the t squared over here? Well, okay. I'm trying to make this look like the lowercase t here, okay? I know those plus signs might throw you off, but this is the lowercase t here, this is the lowercase t here. What is t times t? Well, that's t squared. That's what it is. Alrighty, now how did we get 2t? Well, what we have here is, I'll show you this, we have t times 1 minus t plus t times 1 minus t. How did we get those particular two terms? Well, we multiplied this term times, let's see, first outer inner, okay. We multiplied this times this and got that. We multiplied this times this, and we got that. Well, what is t times 1 minus t plus t times 1 minus t? Well, this is 1t here, this is 1t here. What is 1 plus 1? Well, of course, that's 2. Let me say that again. If you have 1t here and 1t here, and you add up those ones together, 1 plus 1 equals 2. And that's how we got 2t times 1 minus t. That's how we got it. Alright. Now that we know all of this, well, we first know that the x here, we're going to say this, the x, in this case, represents 1 minus t. Just like that. What does the y represent? Well, the y represents t. Just like that. Okay? And that's how that goes. Are you seeing it now? Good. Very, very good. Now, what you do is when you figure out this here and these other terms like this, you're going to multiply it with the coordinates of these points. And that's how you get the quadratic Bezier curve. That's how you do this. Alright? Now then, here's the trick. The trick is, how do we convert all of this information that I just provided to you into SVG? Okay, how do we make the SVG Bezier curve out of all of this? Well, I'm going to consult with Crazy Josh Cravey. Hello there, Josh. How's it going? And D. Lukens9. Hello, D. Lukens9. Hello there. If you want me to, I can place hyperlinks to both of your channels right down here in the description below. That way people can find both of you. And I would like the two of you, based on the information I've just given you, and that website I just gave you, to convert this information into SVG. And when you do, I will give both of you credit for it, and I will make the final presentation, which will hopefully help everybody draw the Bezier curve in SVG. Now, what's the goal here? Well, there's a two-part goal. Number one, I want to help everybody draw the Bezier SVG curve. That's what I want them to do. I want them to draw the Bezier curve in SVG so that everybody can have some graphics. But more importantly, as I was discussing earlier with D. Lukens 9, one of the biggest things I want to do is I want to start adding graphics to my videos. Now, one thing I'd like to ask D. Lukens 9, I had told you previously that if you start making videos in 1080p, that it's going to put a lot of strain on the computer processor, and eventually when you put a ton of strain on that thing, it's going to go out. And I don't want that to happen. Do you see what I mean? So, therefore, what I want to do instead is I want to come up with a file size that's a little bigger than my usual videos, but not as big as a 1080p. The DVD size is a nice size, but it takes a lot of time. And we want something in the mid-range so that I'm not spending a lot of time editing the videos, but yet I'm achieving a better look than I normally get with my less than whatever presentations. Okay? And what I'm going to do is I'm going to use these graphics once I get this fully figured out. And I'm going to use these graphics not only for my thumbnails, because apparently thumbnails is very important in YouTube land, but also I'd like to add these kind of graphics to my videos, my memory videos, my video responses, my weekly VRW contest. I'd love to do that, but I need help. And if you guys can convert this over to SVG, I will give whoever helps me out credit for this. Okay? And hopefully that'll grow your channels as well as you're helping me. Okay, so examine the website. Pay close attention to what I just taught in this video. If I have made any mistakes, please let me know. Because I don't think I have. I think I've pretty much converted this correctly. But if I've made any mistakes, please let me know. And then we'll do all this. Now, I had already discussed in 2 previous videos about the Bezier curve and how it basically works. Okay, and if you guys ask me for hyperlinks on both of those, I'll be more than happy to provide those as well. But as you can see here, this is the basic dynamic of the Bezier curve. It's not that hard. If you combine parametric functions, that's where we get the t from. And I already explained parametric functions in, and I'll say this again, I already explained parametric functions in unit circles. I have a video about that, so you now know where I got the t from. And then I've now explained how you can combine a perfect square trinomial. This right here is a perfect square trinomial. That's what that is. That's what we call completing the square. That's why in the title of this video, you will see the words completing the square. There you go. So, you are combining parametric functions and completing the square to make your Bezier curve. Now, D. Lukens 9, if you ever look up Pappas Book 7, Proposition 238, and successfully draw it for me, I will present it right here on my YouTube channel, and I'll give you the credit for it. Otherwise, Josh, if you can draw it out, that would be great. Otherwise, I'll somehow figure out how to draw it out. I tried to do it in a previous video, but I don't think I got it correct, so we'll try it again. Anyway, that's all I've got to say for tonight. Thank you very much for watching this particular presentation. I will put this in a DVD format. It'll be a little bigger than I normally do, but anyway, I just wanted you guys to see all this clearly. And I want to thank everybody for watching this presentation. Like I say, guys, if you guys can think of a video format, a resolution size, and that's what we're talking about here, the resolution of the video, if you can think of a size that's a little bit bigger than what I usually use, but not as big as a 1080p, that would take a relatively small amount of time to process and wouldn't damage my processor quite as hard, I'd love it. I really would. So, hopefully you can work with me on that, and hopefully you can help me figure this out for the thumbnails. This is something that not only can I improve my own thumbnails, but people who watch this and help me out, they can improve theirs. All right. So, the only other thing I will say to DLucas9 is one of the other reasons why, I mean, I did say that upload speeds are pretty bad, especially around here. Even though I've got the best that there is, it's still pretty bad. And I also said that I don't want to take a whole lot of time editing a video. I want to try to get up on the air as quickly as possible, and I don't want to spend tons of time editing it. But also, because most of my students are facing starvation, eviction, and bullyism, I want to get this information out to them as quickly as possible. And if I'm spending a ton of time editing and then uploading videos, I'm not doing what I told these people I was going to do in the first place. Okay. And yes, DLucas9, as soon as I get a chance, I will continue my Italian lessons, and hopefully I will improve my pronunciation. But the thing is, I'm not really trying to teach these people how to pronounce Italian, although that would be nice. I'm trying to teach these people how to read and write Italian because I'm in the midst of making a Kindle book about how to read and write Latin. And if they understand Italian, they will understand Latin. And that puts the dictionary in their head. Okay, I'm trying to put a dictionary in their head so that they can read faster. That's part of speed reading. See what I mean? Okay, so let me know what you think, and hopefully you guys will help me out. Thank you very much for watching this presentation. I will tell you more in a future video, so I'd like for you to stay tuned.